all of you. Welcome you guys. Welcome you all of you. Yes, all of you, could you please confirm this audio video is clear to all of you, everybody? Yeah, we are starting the offline. So we are coming to the first time we are coming to the offline. In first center is starting in the New Delhi, and you can. So here these are the discount offers. The students who have already taken the subscriptions, those fellows will get a 50% of discount. And the students who have joined in some other institutes, those fellows also will get 50% of discount. And in addition to this early bird offer, 33% discount आपको मिलने वाला. And additionally 20% discount you will get the students whose rank is less than 1000. And the students who appeared in the PSU interviews and are ESC mains clear, those fellows will get a 20% of discount. And so these are the classroom environment. And so we are providing this Unacademy scholarship test, and the scholarship test which is on the 20th Feb at 7 PM. This test is completely online mode mein hoga, and there chance to get 100% of scholarships. And for more information you can visit this our center here in New Delhi. And the last date for registration is 18th Feb. The exam is on 28th Feb at 7 PM. The exam is in online mode. And we are starting the new batches for you, that is Udaan batch and Buniyaad batch. You can find the top educators team you can find here. And the new batch which is started, batch D. So from the February 10th onwards is started. Right now networks is started. And you can follow this my digital codes also. Right, these are the batches we are starting for 2024 as well as 2025. And another new thing here you can see, and we are starting one exclusive batch for engineering, mathematics and general aptitude. And for both EC and electrical we are starting, you can see here. In this batch the Saurabh Thakur sir will handle the aptitude part. I will take the engineering mathematics. And there is chance to get 47% discount आपको मिलने वाला. अभी भी ये ऑफर वैलिड है, so if you want you can enroll for it as soon as possible. And the chance to avail the 30% of discount here you can see, and this offer which is up to 21st Feb only. So try to utilize this opportunity before going to expire by using the code of BV Reddy. By using the code of BV Reddy, you can have a great discounts. Right. Now these are the features for 2025 के लिए भी. And you can use by using the BV Reddy code, you will get it as a 30% discount आपको मिलने वाला. And the rank predictor भी. And these are the features. These are the features. Have a look at here. Yes. Now, so here the thing is you should keep in mind. So whatever you are doing, so that is for your future. You only fail when you stop trying. The students who has not yet performed well, don't worry. So now so this year you have one more golden opportunities. Don't get depressed. Try seriously to achieve the success again. Success will come, it will take time. Remember, hard work never fails. Keep this point in your mind and try your best. Chalo, let's start our discussions. So the digital DPP, I think we have completed the nearly, how many problems we have finished, you tell me? How many problems we have completed? So Boolean algebra we have finished, right? Now let's continue the remaining now here. Let's start discussing the लॉजिक गेट प्रॉब्लम्स. आज हम लॉजिक गेट का प्रॉब्लम्स हम शुरू करने वाला, राइट. द लॉजिक गेट्स विल सी. फाइन. Now let's see this thing. All of you try to participate in the try to give the answer, try to solve the problems, each and everybody. And take the first problem. In the given logic circuit shown in the figure, y is, they ask him to find the y. Now अगर आपने ध्यान से देखा तो here how many levels you can see now here, L1 and L2. How many levels are there? We have 2 levels. As you might know about the, yes, 2 level, we have discussed the 2 level and our logic. 2 level and our logic, which is identically equal to what you tell me, 2 level NAND logic is identically equal to what you tell me, 2 level NAND logic. All of you, now you can see now this is the 2 level NAND logic. So from this what I can say, this I can write it as a 2 level AND logic. So whatever we have in the level 1, even though these are NAND gates, I will treat this as what you tell me now, AND gates ko treat karo. Level 1 we can treat it as AND gate, and level 2 will treat it as a simply OR gate. Yeah, now you tell me now here why. Yeah, बोलिए ना why, what I will get, you tell me. Level 1 we have this is AB plus CD. All of you बोलिए. This is the way to solve this problem. Or what else you can do here, and you can write the expression and each AND gate NAND gate output, and you can simplify. In that case also you will get the same thing. Fine. Next. Now take the next problem. And what is the functionality here? So here देखो इधर how this function will look like, you tell me now here. So this is nothing but, इधर आपको बर्फी दिख रहा कि नहीं बोलो? Are you able to see the बर्फी here? ये कौन सा बर्फी here? NAND बर्फी या NOR बर्फी? What बर्फी here? This is, tell me now here. This is the NAND बर्फी ना? NAND बर्फी तो here क्या है, tell me, which is nothing but XOR gate. NAND बर्फी तो क्या है? So this is nothing but XOR gate. बोलिए. So this is F is equal to X XOR Y. So option A, tell me. Next. For a 3-input logic circuit shown below, the output Z can be expressed as. Tell me now what is the output Z can be expressed as. Here, what is this thing? This is Q now. So here I am getting this as a P Q bar whole bar, isn't it? Next here, this is Q now, so this is QR. Am I correct? Tell me now, telling us what we have taken here, the connection we have considered. So tell me now Z, which is given as, tell me here, PQ bar into Q into QR bar whole bar. No, here also bar is there. So tell me the output, you tell me here what I will get. So which is given as according to the De Morgan's law. Tell me what I will get now here. This is my Q bar plus what we can have, this is QR. Now so the Z is equal to what I will get now here, which is a Q bar by combining these two. Q bar plus QR. So from this what I can say now here, mingle property. So that is Q bar plus R. So option tell me, क्या हुआ आपको? Next. Now tell me now here, A and B are the inputs, they are asking to find the outputs. Yeah, boliye now इधर. So here we have, this is what now here, A bar, and this is B bar. So here what I will get now here, A bar into B bar, and here this is AB. So tell me what is a logic expression here? A bar into B bar plus what? AB. So this is nothing but XNOR gate. Tell me कौन सा option here? Option C. Next. The output of the logic expression is F. Now you tell me now here, this is a Y, so this input is X, this input is Y bar, and this is Y, and this is what you tell me now, X bar. Right, so what I'll get now here, this is X into Y bar, and this is Y into X bar. So tell me the expression, tell me here, this is X into Y bar plus X bar into Y. So this is nothing but XOR gate. Now tell me. Next, the output of the logic expressions. Yeah, tell me now here. Here what we'll get now, this is X XOR with Y. Now the same thing will come as input here now. So that's why here what I'll get this output, you tell me now here. X XOR with Y, and this is what you tell me, XNOR with Z. Right, so from this output F, which is given as, tell me now here, X XOR with Y into what you tell me now here, X XOR with Y and XNOR with what? Z. Now tell me now what we can do, simplifications. So this is, now if I call this as X XOR with Y, let us call this is something A if I considered. Now tell me, this is in the form of A into A X naught Z. All of you. Now I can apply this thing here. Here we have, what is this thing here? And this is in the form of what now here? A X naught Z form. Now tell me, which is given as what? A bar into Z bar plus what now here? A into Z. So this is A into what I'll get, you tell me now here, A bar into Z bar plus A into Z. Yeah, so if we multiply these things, what I'll get now here, A into A bar 0. So then I will get it as what? This is A into Z, and A means what you tell me here, X XOR with Y into Z. So from this what I can say, tell me now here, X bar Y plus X into Y bar into Z. So you can tell me now what will get the option now here, X bar YZ plus X Y bar Z. So कौन सा option, tell me? Option A. Next, in the circuit shown in the figure, if C is equal to 0, the expression for Y is. They has mentioned that here C value 0. If C value 0, this is 1. So this is 1, right? Now here C value 0. Now here what I'll get now here, this is a plus b bar. So tell me now what I'll get now, 0. So this is output here, it is a plus b bar only now. And here this is what you tell me now, ab. Now this a plus b bar, which we can write it as a bar into b bar, I can say now. So then this is what you tell me now, a bar into b bar plus what, ab. So this means, which is nothing but what I can say, this is a x nor b. So then what is a y value, tell me here. This input is 1 and this other input is a x nor b na. So tell me what I'll get here, a x nor b whole bar. So which is given as, tell me here, which is a xr b. So what's the option, tell me here, a b bar plus a bar b. Option A. The output y in the circuit below is always 1. The output is 1. Tell me when the output is 1. Now to identify this thing, first of all we need to get the logic expressions. Yes or no? Tell me what is the logic expression here. So here we will get this as a PQ bar, isn't it? So this is what you tell me now here, this is QR bar, and this is what you tell me now, PR bar. Okay, next here what I will get now here. Now so this is what now here, this is PQ bar into QR bar, this whole bar, and because of this we'll get one more bar, these two bars will get cancelled. So finally here what I'll get, you tell me, this is PQ bar into what you tell me, QR bar, and here this is PR bar. So can you tell me now here why? What I'll get, you tell me now finally, PQ bar into QR bar into PR bar whole bar. Tell me. Now De Morgan's law, which is given as y. So which will get it as a PQ plus what, QR plus PR. So here, have we ever seen these expressions? Yeah, have you seen this expression, you tell me now here. This is nothing but we have given ना, इसका नाम्स बोलिए एक बार. इसको इसके लिए हमने कुछ कुछ नाम्स दिया now, like in the form of AB, BC, AC form or not. This is called as a majority logic circuit. This is called as what? Majority logic circuit. All of you. And this is also called as what, you tell me, self dual expression. स्मरण है कि नहीं? Self dual expressions. और क्या है? This is also called as a carry of a full adder. This is also called as a carry of full adder. एंड और क्या बात है, इसका नाम हमने कुछ और का नाम दिया ना, एक क्या है, टेल मी, इसका मिन टर्म्स बोलिए. व्हाट आर द मिन टर्म्स ऑफ दिस एक्सप्रेशन, यू टेल मी. व्हाट आर द मिन टर्म्स आर 3, 5, 6, 7. इसका मिन टर्म्स क्या है, 3, 5, 6, 7. सो व्हाट इज दिस, दिस इज, ये तो आपका फोन पे नंबर है ना, ये तो आपका फोन पे नंबर है कि नहीं, बोलो. राइट. सो दिस इज कॉल्ड एज a majority logic circuit. Why it is called as a majority logic circuit? What is the condition for the majority logic circuit? If more than two 2 or more number of inputs are 1, output is 1. Yes or no? You tell me now here. कौन सा option? कौन सा option? Tell me now here. If more than 2 inputs are 1, output is 1. Then all of you. More than 2 inputs are 1, output is 1. Yes? Chalo. Next one. The output of the logic circuit given below is, tell me, the output of the logic circuit. So this is what you tell me now, X, and this is what now, X bar. Tell me now here, F is given as X, XR with X bar. So tell me now what is the output now here, X, X bar. So the different input case output is 1 now, tell me. अगर different inputs दिया तो output is 1. XR gate is the inequality detector. XR gate is what? Inequality detector. Remembered or not? XR gate is a inequality detector. Sorry, XR na, sorry. XR gate is a inequality detector. Next, for the output F to be 1 in the logic circuit shown, the input combination should be, I need the F value required 1. I need the F is required 1. For that, what could the input combinations? Now you see this thing, this is what gate you tell me now here? This is XNOR gate. This is what gate you tell me? XNOR gate. When the output of XNOR gate is 1, you tell me? When the output of XNOR gate is 1, for odd number of ones or even number of ones? XOR gate is what now here? XOR gate. What is the property of XOR gate is a? XOR gate. So in case of a, what to tell me? Even number of ones, 1. And XNOR gate output is 1 for odd number of ones. Odd number of ones, it should be 1. Now you can check it now here. So option से verify करने के लिए सब कोशिश करो. Now you tell me now here option A मैंने check किया तो here this is 1, 1 and 0. Tell me here 1, 1. Here this output is 0. So here 1, 1, this is 1 and this is 0. Is this output is 1 or not? You tell me. Is this output is 1 or not here? XR. So in this case, what we required? You tell me now here. Even number of ones required or odd number of ones required? XR के लिए, don't get confused here. XR के लिए, XR case output is 1 for what you tell me now here? Odd ones. Odd number of ones. For odd number of ones, output is 1. Now here XNOR के लिए output is 1 for even number of ones. Even number of ones के लिए. Now check it now here. Here we have odd number of ones now. So ये तो गलत है ना. So this is not. So let's check the second one here. This is not. Second one is 1, 0, 0. Tell me now here. This is 1. This is 0, 0. So here odd number now. So this is also not correct. You need to see this. We have to see. Here we have how many ones are there? Odd number of ones. So that's why this is wrong. Next option C check करो. 0, 1, 0. So 0, 1 means this is 1 and this is 0 and this is 0. So ये तो wrong है ना? Tell me. Remove this also. Now tell me now 0, 0, 1. 0 0, so this value is 0, this is 1 1. You see how many number of ones here, you tell me, for the input of x naught, you tell me, or even number of ones are there or not? Even number of ones are there, so that's why output is 1 or f is equal to 1. So when you tell me now for this input, now tell me, so option D is correct. Done. Next, now the logic circuit shown in the figure. Tell me now here, what is the logic circuit here? So here which is given as, this is my x bar and this is y bar, and here this is y and this is x. See here what I will get here, x bar into y whole bar, here x into y bar whole bar. Now you tell me what I will get my output here, where my output z is equal to what, x bar into y bar x into y bar whole bar. So from this z which is given as, what I can say here, x bar into y plus x into y bar. So this is nothing but what you tell me now here, XR. This is nothing but XR gate. Fine all of you. Next, which are the following Boolean expressions correctly represent the relation between P, Q, R and M1? Yeah, tell me now here. What I will get, this is PQ. So here we will get this as PQ bar, and here we will get this as a P plus Q. Next here what I will get, you tell me now here, this is PQ bar plus P plus Q. Sorry, into, now this is AND gate, right? This is P plus Q. Now here this is R, and let us simplify this thing better. So then M1 which is given as, what I can say here, this is P bar plus Q bar into what you tell me, P plus Q, and this whole thing is XR with R. So you tell me now here this M1, so which is given as, and we can apply the T2 here. So then P bar Q plus PQ bar XR with what you tell me, R. So the inside part which is nothing but what you tell me, that is P XR Q XR with R, and as, so from this what is the option, you tell me? Option D. Next, for the circuit shown in the figure, the Boolean expression for the output Y in terms of PQRS is. Now you tell me now what I can say, this is my P bar, this is Q bar, R bar, S bar. Now you tell me what I will get now, this is P bar into Q bar whole bar, and here also this is P bar S bar whole bar, and here because of this NAND gate, so again complement P bar into Q bar. here R bar into S bar. So you tell me now what I'll get finally Y, which I will get this thing as P bar Q bar into R bar S bar whole bar. So tell me what I'll get now. De Morgan's law, P plus Q plus R plus S. Done. Next. Yes. Here is a bubble is there. Okay. Now try this one here. Here is BC. So here what I'll get to tell me now here B plus C. Now here this is what now here BC. Now so here it is A into B plus C. Here it is A into B plus C. And here this is A bar into BC. Tell me all of you. And so from this what I can say now, this X which is given as AB plus what? AC plus A bar BC. So now you can tell me now here this is now, so this is if I say AB plus, now if I take the C common here, then it will becomes what you tell me now here A plus A bar B, right? Now what I can do, tell me, I can apply the mingle property here. C into what I can do here, this is A plus B. Now so which is given as what? AB plus BC plus AC. So tell me the option here, C. Next, the output of the combination circuit given below is, yeah, tell me the output here. Here I am getting this as AB. So here which I am getting this as a BC. Now here C is going to here, so then it is ABC, right? Now here AB is another input here. So what I can do, this is AB XOR with BC. AB XOR with BC. Now tell me now why, what I will get here. So which is given as ABC XOR with what you tell me, AB XOR with what you tell me now, BC. Now here from these two I can take out AB common. If I take out AB common, then it is C XOR with what? 1. XOR with what you tell me now here, BC. Now you tell me now what I'll get here. This is now AB into C XOR with 1. So which is given as what we can say, complement na, if the input is 1. So it will be like inverter XOR with BC. Now why? Here I am taking this as a B common. Then it will becomes what? C XOR with AC bar. ये प्रॉपर्टी आपको याद है ना, बोलिए. Now in this case this XOR gate will behave like what you tell me now here. It is nothing but C plus A. हाँ ना बोलिए, this property आपको स्मरण है कि नहीं? So we have seen this is A XOR with A bar B, and which is nothing but what you tell me now here, A plus B. A property we have used here. So कौन सा option tell me now here, B into C plus A. Next. Now, so what I'll get now, this is X Y bar. X Y bar. Now this is Y bar. Next, this is Y bar into Z whole bar, which is given as a Y plus Z bar. Y plus Z bar. So finally the expression F, which is given as X Y bar into Y plus Z bar. Now, so check the option now. ये हुआ तब किसी और फॉर्म में दिया, whole bar is there, no? Fine. Yes. Now you tell me now here. So this F, which is given as, what we can say, this is XY plus what we can say now here, Y plus Z bar for this whole bar. So then F is given as, what I can say here, XY plus what, Y bar Z. Now check the option here. Option B. Next, in the figure shown, the output Y is required to, Y is equal to AB plus C bar D bar. What will be the gates G1 and G2? Yeah, you tell me now. I require this Y value. What we require, you tell me now here. This is AB plus what I can say here, C bar into D bar. Y is equal to AB plus C bar into D bar. Here what I am getting now, you see this thing, C plus D whole bar, and which is nothing but C bar into D bar. Fine, this thing as it is here is there. So means this must be added, means I should call this as a OR gate. And here I need to get, what you tell me, AB I need to get. Then I can directly add them now here, AB. Next, here we have, this is what you tell me, A bar, and this is B bar. And how we can get this AB from this, if the inputs are A bar, B bar? So tell me now, if G1 is a NOR gate, if G1 is a NOR gate, tell me what happens, you tell me here. Here this output, what I will get here, this thing here, this is A bar plus B bar whole bar. So that it will becomes, what we can say now, AB hoga na boliye. So that means what could be the G1, you tell me. So G1 must be a NOR gate and G2 must be a OR gate. All of you tell me. G1 is a NOR gate and G2 is a OR gate. Next, the circuit shown in the figure realizes the function. The circuit shown in the figure realizes the functions. Here, tell me now, what is the expression here? F, if I say, this is what you tell me now here, A plus B whole bar. And this is what we can tell me now, A plus B bar plus C whole bar. Now this is D plus E whole bar, and this is D plus E. Bar will get cancelled. Now tell me what is the final output F, which is given as A plus B bar plus C whole bar plus D plus E whole bar. Now you can see the output now here. A plus B bar plus C into D plus E bar. De Morgan's law. So what I will get, you can see. Check the option now. कौन सा option here? Now this is option D is there now. So this is A plus B bar plus C into what I can say, this is D bar into E bar. Option D, tell me. Next. Now the logic circuit they are asking. Logic expression here. So we need to see the shaded part. If I call this is a 1 and if I say this is the second part, so there are shaded regions you see, and we need to talk about the shaded parts we should see here. Now tell me the shaded parts here. So this is this part. What is this value? Tell me here. Here we have A is there and B is there, but there is no C. So that's why C bar I can say. Plus second part, here what we have is there is no A, B is there and C is there. Check the options. That's all now here. So what's the option here? Option C. Next, the number of Boolean functions that a function can have. Tell me how many Boolean function it can have, you tell me. The number of Boolean functions it can have by using how many variables now? 4 variables they are saying. That means they given the n is equal to 4. N is equal to 4. Isn't it? The number of Boolean functions. Tell me here, what is the formula for the number of Boolean functions? Number of Boolean functions. The number of Boolean functions. Boolean functions, logic expression, switching function, all are same. How many here? 2 power n. The number of Boolean functions are 2 power n. So how much we can say? 2 power n. How much is n value? Tell me. 4. So we can write this as 2 power. So this is now 2 power 4. We'll get it as 4, 4 to 6, 4 to 8, 8 into 16. Isn't it? This which we can write the 2 power 10 into 2 power 6 I can write now. 2 power 10 means how much this is? 1024. And 2 power 6 means how much we can write now here? That is, so this is how much this value? 32, here 256. 2 twos 4, 4 twos, yes, correct only now here. Now here, so how much we'll get now here? This is, so which is equal to 2 power 5, 32, 64. So which is equal to 64. So how much this value? Tell me. 65,536. So these many Boolean functions are possible. All of you. Next. Yeah, try this thing. The minimized Boolean functions. The minimized Boolean function which is equal to what? If I call this output is y. Now you see this thing, how these two are now here parallel and this is series. So what I can say, this is A into B plus C bar plus, and these terms, what I can say, a bar into b plus a plus b bar into c. So tell me now y, which is given as ab plus ac bar plus a bar b plus ac and b bar c. Now try to minimize it now here. If I combine these two, then what I'll get now here, b. Now if I combine these two, I'll get the a plus this is b bar c. Now in these two we can do mingle property. Then tell me now what I'll get now, this is a plus b plus c. Next, the number of switching functions, 3 variable. How many switching functions are, tell me, 2 power n. So that means 2 power 6. So how much is value now? 2 power 6. 2 power 6 means, sorry, 3 value now. N is equal to how much? 3. Sorry, n value 3. So means how much is value? 2 power 8. 2 power 8 is how much, you tell me here? 256. Option D. Next, yeah, tell me the switching function here. If I call this output is y. Now here how these two are, tell me now here, parallel. So we can add them. These two parallel and the whole combination is series. So tell me what I can say now here, b plus c into what you tell me here, d plus e, and so plus f, and for whole thing a is in series now, tell me. So कौन सा ऑप्शन चेक करके बोलिए? What's the option? ये one. The Boolean expression for the shaded part. Shaded part. So how we need to do? We know now. This is my one. If I call, this is the second region and this is the third regions. The shaded part we have to consider. So that is F. Here we have A is there, B we have no C, plus here we have A, no B and C, second region, and third region. So there is no A, B is there, C is there. So कौन सा option, tell me? Option B. Playlist of EMF videos are there now. EMF videos are there now. Want to find this is Sital? Want to find the EMF playlist? Yeah, you message me, so I will share it. I will share the playlist. I will share you EMF thing. Next, take down next one here. YouTube पे yes, in YouTube we have. In a digital system, there are 3 inputs A, B, C. The output should be high when at least 2 inputs are high. Output is high, at least 2 inputs are high. Means what you tell me now here? So this is called as, they given the condition is what you tell me now here, output which is equal to 1. Tell me now here when at least 2. So at least 2 means what I can say, tell me now here, 2 or more than 2, at least 2 inputs are high. At least 2 inputs are high, the output is 1. That means this is called as what you tell me now here, this is called as a majority gate. This is called as what you tell me, majority logic gate. हाँ ना बोलिए, this we have discussed now. Majority logic circuit, 2 or more than 2 is 1. So what is the expression? So in case of majority gate, can you tell me the min terms? What are the min terms of majority gate? Is a 3 5 6 7. 3 5 6 7. So then, so what is the logic expression? You tell me now here. The logic expression which is given as, tell me now here, A bar B C and A B bar C plus A B C bar plus what? A B C. This is the logic expression. And so by minimization of this thing, so we'll get this expression as a AB plus BC plus AC. हमने डिस्कस किया इसके बारे में, बोलिए इसमें कोई डाउट हुआ? So that means you can see this option A is correct, option B is correct. So this is the MSQ. Okay, both A and B are correct. Then everybody, you can see now a bulb in the staircase has two switches. One switch being at the ground floor, other is the first floor. The bulb can be turned on and also can be turned off by any one of the two switches, irrespective of the state of other switch. The logic of the switching bulb resembles, tell me now here, the staircase switch. इसके बारे में हमने डिस्कस किया. This is called as a staircase switch. Staircase switch. What is the working of a staircase switch, which is based upon what you tell me? XR में depend होगा. The staircase switch will work based upon the XR logic, not AR logic. It depends upon XR logic. So that is option C. XR, so staircase switch means two-way switch. In your home you have two-way switches now. One is at the main switchboard, the other one is at the आपका बेड के पास होगा. So if any one of the switch is on, the bulb will be on. If both are off, off. Both are on also, off only na. That is a staircase switch. Next, match the logic gates. So match this thing here, all of you. Now this is a bubbled NOR gate. As you might know, we have discussed this thing here. Bubbled NOR gate. Bubbled NOR gate, and which is identically equal to what you tell me here? Bubbled NOR gate, which is identically equal to what you tell me? So this is a, tell me, remember this thing or not? So this is a AND gate. Hana bol. Next, bubbled AND gate, bubbled AND gate, which is equal to what you tell me? NOR gate, vice versa. Isn't it? Now you tell me now here. Bubbled OR gate equal to what you tell me? Is equal to the bubbled OR gate equal to NAND gate. And bubbled NAND gate equal to what? Bubbled NAND gate equal to what you tell me now here? OR gate. Now you can able to answer it now here. This is a NOR gate. NOR gate is equal to what you tell me now here. So here NOR gate, which is equal to bubbled AND gate. So you can see now this is the bubbled AND gate now. So for this we have option 4. And NAND gate equal to what now? Bubbled OR gate. So this is the 2. And you see this thing here. XOR gate here we have. So this is single bubble. So this is the 3. And this is a 1. Check the option of here. 4231. 4231. Option D. All of you. Next. Now tell me this one here. A, B, C, D are the inputs. Y is the output. Okay, XOR gate they given. Which are the following statements about the sum of A, B, C, D and Y is correct. Sum of A, B, C, D. Now, if you see carefully, what is the logic you tell me? First of all, this is here we'll get A XOR B. Here we'll get C XOR D will come. What is a Y you tell me? As we know, XOR gate will obey associative property. So we can write this thing as A XOR B XOR C XOR D. Fine. Now, to understand this thing here, look at now here, we should develop one table. Here we have taken A, B, C, D. And this is my output. And here this is sum. Here we have taken A, B, C and D. And here this is my Y output, which is given as what you tell me? A XOR B XOR C, C XOR D. And the yes, sum is what you tell me now, which is given as A plus B plus C plus D plus Y. First of all, आपका table समझ में आया बोलो? So these are table formations. Now you see this thing, the inputs of A, B, C, D. Let us consider all these inputs are 0, 0, 0. Now tell me when the output of XOR gate is 1 for odd number of ones. Here we don't have odd number of ones now here. So output is 0. Y is equal to 0. And whatever the sum you tell me, sum is equal to here sum of A, B, C, D plus Y, which is value 0 only now. Now let us consider this is other input is in this form. Yes, let us consider here one of the input is 1. One of the input is 1. Let us consider. They are the different cases. You see this thing now. In all these cases, what you observe here, only one input is 1. Agar any one of the input is 1, so can you tell me the y value what I will get here? 1. Output is one odd number of ones. Now in this case, can you tell me sum what I will get here? In all these cases, so here sum of A, B, C, D, which is 1, 1 plus 1, so which will get it as a 2 now, tell me? Decimal. Next, what are the other possible cases you can take, you tell me? Other possible cases. Any two inputs are ones. In this case, I am taking 0, 0, 1, 1, 0, the DPP discount will be taken on Kreatryx, not on app. Yes. So this is 1, 0, 1, 0, 1, 1, 0. Like this, different combination possible now, tell me. Like this we can do here. Some combinations we can take. Now I have to take few combinations. So this is 1, 0, 0, 1. These are the combinations possible, you see. In these cases, you tell me what in all these cases, can you tell me what is the output here? What is the output here? Here we have an even number of 1, so output is 0 now. Can you tell me now sum of these things now here? Sum of A, B, C, D plus Y, which will get it as what you tell me now? 2 now. In all these cases, I will get this as a 2 will come. In all these cases, हमको 2 मिलेगा. Check करके बोलिए. All of you. Next. Now, even if you have considered some other case, let us say other cases, even if you have considered, now you tell me now here, A, B, C, D. Now you tell me what I will get. Now here, this is A, B, C, D, and here this is my Y, and this is the sum. Tell me the possible other combination. We can take it as 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0. Like this I can take now. In all these cases, can you tell me the what is the output? Y will becomes 1 odd number of ones now. Can you tell me the sum kya hoga? 3 plus 1, so which is equal to 4. And what the other case now here? I will take all ones I can take now. In this case, what is the output is a 0. Yes, XOR gate output is 1 only when the odd number of ones inputs are ones. Whatever the sum in this case, you tell me now 4. Now you see the option now what they are asking here. What they are asking here regarding the sum, they are asking the options they given. What could be the sum? You tell me. Sum, yes, is always either 0 or odd. Now you see this thing. What I got the sum? You tell me here. S is equal to 0. Here we got 2, 2. Here we got 4, 4. That means what we can say, sum is either 0 or even. All the cases sum is even. Now tell me. So sum is always either 0 or even. चेक करके बोलिए. All of you tell me. Understood this problem? Tell me, all of you. Yeah, this is the one good problem. This is a PYQ. It's another good problem. Another twisted question. Clear now this thing? Tell me, all of you. Chalo, let's move to the next one. Yeah, tell me now here. In this case, the point P in the following figure is struck at 1. struct 1. We have two different type of faults. We have one is struct 0, struct 1. We have two faults. We have one is called as a struct 0, struct 1. These two are the faults. What is the struct 0 means now here? What they given now here? At the point P, here we have struct 1 fault. That means, so here because of some mismatch, some issue, some defects and all, at this location I am getting the output is always 1 only. Then we can call that as struct 1. So whatever it may be the previous things, so it does not. So because of some defects, connections and all, at this location I am getting always 1 only I am getting. That is called as struct 1. Here they given the fault is what you tell me, struct 1 is given. That means here it is which is always 1 only. So irrespective of the previous connections. Okay. If this is 1, so this is a NAND gate now, so this will become 0. And so here we have something, we have, let us say this is something fx. If I say here in this case it will work properly, but here if I say something x, can you tell me what I'll get here? 0 into x whole bar, so which is equal to what? 1. So this is 1. Now here this is what you tell me now, a bar, and this is what you tell me now, a. So the answer is D. All of you. Here at the point P we have struct 1. Means what now? Irrespective of the previous connection, at this location the always the value which is always 1 only. That is a struct 1 fault. Now see this thing here. A digital circuit which compares two numbers, the shown in the figure, the output y is equal to 0. For the output y is equal to 0, they ask him to choose the correct combination of inputs. And this is which gate you tell me now here? NOR gate. This is NOR gate. If any one of the input is 0, output will becomes 1, isn't it? So the NOR gate output 0 means what the condition you tell me now here? We should not get any 1 here. Yes or no? Here we need to get this is 0 zeros. Now check it now here. Here this thing here, a value given as what you tell me, first option 1 0 1 0. B option is what you tell me now here, 1 0 1 0. Check this option here. Now here 1 1, here given 1 1, this is 0 0, next 1 1, and this is 0 0. So see what I'll get the output, you see 1 1 XOR gate now, so this output is 0, and here this output will get what now here, 0. Yes, equal inputs, output will get 0 now. So all inputs are 0. Because of this we'll get the y value, will get it as a 1. So because of this my output which I will get it as 1. But लेकिन मुझे क्या चाहिए, y value 0 चाहिए ना. So this option is wrong. Now see the second option here. A value given as 0 1 0 1. And the B value which is given as what you see this thing here, so 0 1 0 1. Yeah, in this case also you tell me what I'll get the output. Yes, 0 0 1 1 0 0 1 1. So tell me what I'll get. So here this value 0 0 0 0. So from this what I can say now, because of this I'll get my output. What I'll get my output here, tell me? I will get this output, which I will get it as a, so 1. So that's why this option B also wrong, now tell me. Now check for option C. A value. A value given as what you tell me now, 0 0 1 0. B value given as what, 0 0 1 0. Now check for the option C also. In this case 0 0 0 0 1 1 0 0. In this case you tell me now what I will get this output, this value 0 0 0 0. So because of this also will get the output is 1 will come now, so this option is also wrong, isn't it? Next option D, tell me. 0 0 1 0, this is A. A is given as 0 0 1 0 and B is given as 1 0 1 1. Tell me in this case क्या होगा? So yes, 1 0 0 0 1 1 0 1. Here we'll get 1, this is 0 0 1. So what is this output here, tell me here, which is equal to 1 plus 0 plus 0 plus 1 for this whole bar. So which is given as, tell me now, 0 now. That what we require, you tell me. In this case my y is equal to 0. So I can say this is my option, tell me. Done. All of you. Everybody. So what you fellows are doing? So come on, all of you be active. Done. Completed this problem, all of you. बोलो यहाँ. Yes. आज हमारा टारगेट तो आपको पता है ना. So we are targeting, so with class 60 problems we need to finish it. So आप इतना डल है तो how we can do this thing? 60 problems कैसे खत्म करेगा हमने आज? थोड़ा जोर से be active everybody. Done. Yes. सभी ने एक बार बोलिए, आहा महादेव शंभो शंकर. एक बार लॉर्ड शिव को जय बोलो सभी ने एक बार. सो आज तो महाशिवरात्रि का फेस्टिवल है ना. Are you fellows are doing fasting or not? Huh? Anybody are doing fasting? सभी ने एक बार बोलो, सभी ने एक बार बोलो, लॉर्ड शिव को जय बोलो एक बार. Now tell me now here, the logic circuit of the figure is. Now tell me now here, what I will get here, this is my AB. And here I will get it as A bar into B bar. So tell me now why. Why, which is given as, tell me here, A bar into B bar plus what? AB. Done. So that means what the expression here, which is nothing but what you tell me. This is a X NOR B. X NOR B, which is also called as a equality detector. X NOR gate, which is called as a equality detector. X NOR is called as what gate? You tell me now here. Equality detector. So option C. If the input to the digital circuit is given, so how many gates are there? Totally 20 XR gates we have. Now we need to find the output here. 20 even number, so let us take simply n value equal to करके verify करो. Tell me now n value 2 means यहाँ तक find out करना पड़ेगा. Now you tell me what I'll get here. This is 1 XR with X. What I'll get now here? X bar will come. This is X bar and this is X. So what I'll get here? So this is X bar XR with X. What I'll get to tell me? 1. So tell me what is option here? 1. Everybody? Next. The output of a logic circuit is 1 when all its inputs are at logic 0. When all its inputs are logic 0. Tell me this thing here. Output is 1 when all its inputs are logic 0. When it is happens, you tell me A, B and Y is my output. Now you tell me now here. All input 0, 0 we have taken, output is 1. You tell me now which cases output is 1 here. In case of a NAND gate, output is 1. Hana bolo. And the NOR gate is also output is 1 here. And what else you tell me? Even in case of a XNOR gate also output is 1. Hana boliye. These three gates output is 1. So tell me the option here. So NAND D chalega, NOR chalega, XNOR chalega. So option D. The output of the circuit is, tell me here. Here they given this as A. This is XNOR. A XNOR B bar. Tell me what I'll get here. A XNOR B bar. Single bubble XNOR will gives what you tell me now. XR आएगा ना. If I have taken one time, so XR will come. And this is tell me A XNOR B bar. Single bubble. So what I'll get to tell me now here. This is also XRI. So both are XR. So this is XNOR gate. XNOR is a inequality detector. So that means output क्या होगा? Tell me. Which is equality detector now? Tell me. So the same inputs if you have given, output will becomes 1. Isn't it? Same inputs are giving now. So that means A XR B XNOR with what you tell me? XNOR with AXRB. Same inputs we have given. Output equal to 1 na. XNOR is called as a equality detector. If both inputs are same, output will becomes what? 1. Next. For the logic circuit shown in the figure, the condition for ABC for X is equal to 1. That means they are saying this X value is 1. This output is 1. When this, for what combination of inputs output is 1. And you see this thing, this is what gate here it is a, and here this is a AND gate. When the output of AND gate is 1, when all the inputs are 1, then only output is 1. Yes or no? This means this value 1, this must be 1, this must be 1. Then only we'll get the output is 1 na. So this is 1 means I can say this must be C must be 1. Now this is XNOR gate. XNOR gate, when the output is 1, when the both inputs are same, this value already 1. For the output to be a 1, the condition is this also must be 1 only na. That means B value 1, and it is XOR gate. When the output of XOR gate is 1 for different inputs, this is already 1, so this must be 0 na. So means what I can say, A must be 0, B must be 1, C must be 1. Yes or no, tell me. In this cases chalega. No, option A does not satisfy, केवल D satisfy. Now see, the conditions are now basically they are saying that, so they are saying what they are saying, you tell me now here, output must be 1, so that means this X value must be 1. You tell me now, this is which gate, you tell me now here, this is what gate? AND gate. You tell me now, when the output of AND gate is 1, when the output of AND gate is 1, if provided all the inputs are 1, then only output is 1. Hana boliye. Output of the AND gate is 1 if all the inputs are 1. What is the expression for AND gate is a y, which we can write it as what now here it is A, B, C will multiply now. If all the inputs are 1, then only output is 1, isn't it? That means this input must be 1, this input must be 1, and this input must be 1. All the input must be 1. Yes or no? So this input is 1. See this connection here, from where we have a connection, kahan se aaya? You see this thing here? Yahan se aaya. That means this is nothing but C na. So can I conclude the C must be a 1? I can conclude the C must be a 1. Now that means the same connection given to here. This means this input is 1. C is 1, isn't it? And this is, now you tell me now, this is which gate here? This is a XNOR gate. When the output of XNOR gate is 1, when the output of XNOR gate is 1, for equal inputs or unequal inputs is 1. XNOR gate output is 1 only for the equal inputs. So this input is already, we know this is 1. For the output to be a 1, the condition is what now? This input must be also 1. This input must be also 1. This input is 1 means A input, you see the connection now kahan se aaya? Yahan se na, yahan se idhar. This thing here. That means I can conclude the B must be a 1 na. Now same B is going to here also. That means this input is also 1. Now this gate is what you tell me now here. This is a XOR gate. XOR gate. When the output of XOR gate is 1, when the output of XOR gate is 1, equal inputs or unequal inputs? Unequal inputs, XOR gate is 1. Unequal inputs, this is already 1. Unequal means this must be what you tell me? 0. Then only it will be a 1 na. Then only the output of XOR gate is 1. So now you see this thing here, this input, this value 1, this is 1, this is 1. Then only output of the AND gate will becomes this thing. So what is the value of A here? A is equal to 0, B is equal to 1, and C is equal to 1. So these are the combinations, you tell me. That is a way we'll analyze it. Is it fine, all of you? Tell me. Say the next problem. The operator x XOR y bar is what? So we have discussed this property here. If we have one time bubble is there, one bubble is there, what happens now here? This bubble and this operator will get multiplied now here because of this bubble. The operator will become changer. Now tell me. So this is x XOR y, all of you. So this will get it as XOR gate. Everybody. Next, the expression. I think we did this problem also previously. Tell me the answer for this thing, fatafat. Now if I call this is 1 and this is 2. Yes, tell me now here. First one is y if I call. Here we have A is there, B is there, no C. Plus no A, B is there, C is there. So tell me the option here, C. Repeated, I think so, this problem. Now tell me this thing here. A plus A bar B Boolean expressions. So they are asking this expression as A plus A bar B. So can we minimize this expression further by using mingle property? If I use it now, tell me what I will get here. This is A plus B hoga na. By using the mingle property, this is A plus B. That means A plus B XOR gate is required. Tell me A plus B, which is A plus B here? So whole A, whole B, yes or no? So this is the option you see. इसमें complete A, B दोनों में ना. This is complete A, complete B is shaded part, isn't it? Can you tell me now what is the logic expression of this B, the remaining also? Can you tell me now what is this expression here? This is nothing but A into B, intersection of A, B. Now बोलिए. And what about the C? Tell me now here, this expression here, which is equal to A plus B whole bar. This is complement of this XR. Now tell me. So A and C are complement to each other, you see. And here Y. So in this case completely this is 1. Why? Because all part, complete universal set is shaded part na. Universal set is shaded. So that's why this is 1. All the terms we have. Next. See this. Yeah, so I think so the same problem given in this year, GATE 2022 for instrumentations. Same problem has given. Instrumentation they given same problem. Right. Now you see this thing here, A XOR B equal to 0. When this condition happens, that means equal inputs will happen or unequal inputs will happen, tell me. Equal inputs are happens or unequal inputs happen. A XOR B equal to 0 means it is the equal inputs, which is 0. Now tell me. Now you see this thing, A XOR B is 1. When this have an unequal input, so this is second one, first one here. Now and here A plus B whole bar equal to 0. When this scenario will happens now here, third one, when A is equal to 1, B is equal to 1 will get now. Next, this is A bar B. So tell me now here, this is the fourth. Check it all of you, this condition. Now so option 2, 3, 4, 1. Option B. Next one. The Boolean function AB plus CD plus E can be realized using what? So they has implemented by using the NAND gate से implement किया. Yes or no? Yeah, tell me now कौन सा option here? So here this is a NOT gate here. This NOT gate will behave like a NAND gate. Yes or no? Single input only na. So you can see this कौन सा option here? Tell me now here. Option A or C. A or C में doubt होगा आपको. Isn't it? Now tell me इसीलिए मैंने इसके लिए बोला. So this is now here AB when we have the function which is given as AB plus CD plus here we have E. I can write this thing E as a E into E I am writing. E into E I am writing. Now you tell me this thing क्या होगा? So here we should write this thing as what you tell me now. All this as with a NAND gate से replace करना पड़ेगा. This is a I can use one AND gate, one AND gate, one AND gates. So this is nothing but what we can say here. That is two level AND OR logic, which is equal to what you tell me. Two level AND OR logic, which is nothing but what I can say here. Two level NAND logic, which is equal to two level NAND logic. All of you here to confuse they given this as a in place of this NAND gate they given as a NOT gate. So you treat the NOT gate as a NAND gate, then it is fine. Next, yeah, tell me the next problem. Yeah, what is this thing here? This is the open collector wired connections. In this case, when we have the connection like this, you treat this as it is like a AND gate. This we should treat it as what you tell me, AND gate you treat it. Okay. तो इसके बारे में हमने लास्ट चैप्टर में डिस्कस करने वाला. Why it is like this. Here we have AB bar into what we have. This is A bar, B bar, whole bar. So tell me what I will get here. This is A bar plus B bar. Yes, into what I can say. This is A plus B hoga na. And which is given as, tell me now, we can apply T to A bar B plus AB bar. So which is nothing but what we can say, tell me now here, A XOR B. Option C. Next. Yeah, tell me now this logic expression here also. Now here this is multiplied. Now this is the AND gate now. So here this is what you tell me now, AB whole bar, and this is what you tell me, A bar B bar whole bar. So this is the AND now here. So that's why it is multiplied. Now why it is added? So this is what now here. Assume this here we have an AND gate. In the last chapter, we'll discuss about the concept of what is open collector logic. You treat the interconnection that is AND gate. अभी so here बाद में आपको पता चलेगा what is meant open collector when you are discussing the logic families. Yeah, tell me now here. Here This input is what now? X, and this input is Z. What about here? You tell me now here. This one, this input which we have, finally F, I can write it as X plus X bar Y Z bar whole bar plus Z. Then which is given as X plus, tell me here what I'll get. This is complement, we have taken X plus Y bar plus Z plus Z. So tell me what I'll get now finally, which I can say this is 2 times repeated, we can remove one na, plus Z. So which I can write it as, this is now X bar Y Z bar whole bar. This is operation, you see. कौन सा option, tell me now here? Option A. Next, which are the following is a coincident? Coincident logic means what, you tell me now? So like it is a XNOR gate. Coincident means what, you tell me now? That is a equality detector. XNOR gate is called as a coincident logic. Which is the coincident logic, you tell me here? So here if we see this thing here, this is my XY and this is X bar Y bar. So tell me what I'll get now. Option A here, XY plus what I can say here, X bar into Y bar. So this is a coincident logic na, XNOR gate. Next, the gate whose output is low if and only if all the inputs are high. Tell me now here A, B and Y. You tell me now whose output is low only when all the inputs are high. In which cases this happens, you tell me? Here output is low only when all the inputs are high. When both are 1 1, so in which cases output is 1, you tell me? In these cases, so what happens, tell me now here. अगर आपने ध्यान से देखा तो can you tell me now this NAND gate? Yes, NAND gate, or so here NAND case, you tell me now here. So when you have taken input 0 0 0 1 1 0 1 1, tell me the truth table here. 0 0 which is 1 1 1 0, isn't it? If we have taken a NOR gate, we have taken, tell me now here, this is A, B and Y. So tell me 0 0 0 1 1 0 1 1. Tell me the output here, this is 1 0 0 0. You see the condition of the statement what they given. Yes, whose gate output is 0, output is low when if and only if all the inputs are high. You see this thing here. In this case, this condition satisfied. In this case also this condition satisfied. But here the word if and only if is very important. Only when all. If you see carefully, in case of a NOR gate, you see this thing here. In this case also output 0. In this case also output 0. In this case also output 0. Yes, but they are saying that only this condition, only if and only if, only this condition satisfy, only this NAND case satisfy na, NOR case not satisfy, you see? Yes sir, now tell me. So that's why only option A. Any doubt in this thing? Tell me. The words is important. They mention that word of if and only if. Clear ना बोलिए. Next. Yeah, so this is not a bubble, okay, this is just a connection. Tell me now, what is this thing? This is a bubbled AND gate. Bubbled AND gate is nothing but NOR gate na? Bubbled AND gate. Bubbled AND gate, which is equal to what we can say here? NOR gate. Then, next, which are the following sets of the gates are best suitable for parity checking and parity generation? For the parity check and parity generation case, we prefer the XOR gate and XNOR gates. So this thing हमको will study this thing in the combinational circuits में आएगा. थोड़ा बाद में आएगा this thing. As of now, you do remember for the parity checking and parity generation, we prefer which gates? XOR gates and XNOR gates will we use. Next, the output of the logic gate is 1 when all its inputs are logic 0. Tell me now, output is 1. So this means here they didn't mention the condition if and only if condition. Here we don't have any if and only if condition, right? A be given. So you can tell me now here, output is 1. So when both inputs are 0, 0. When it is happens, you tell me here which cases will happens. This will chalega for this will work for the NAND case chalega, and this will work for the NOR gate also, and even this will work for what else you tell me now here, XNOR also chalega, isn't it? So tell me the कौन सा option here? Okay, in this case, what's the option you tell me? NOR and XNOR. Next, a 3-input NAND gate is to be used as an inverter. Which one of the following measures will achieve better result? So what we will do here? Yeah, tell me now here what I will do here. I need to use a 3-input NAND gate as an inverter. So that means inverter means NOT gate. It has only one input. So you tell me now I have a NAND gate is there. So NAND gate, they are saying that we have 3 inputs are there. So but I need to use this as inverter. If I give A, that means we need to get the output as A bar will come. Now what I need to do the other 2 inputs? What I have to do other 2 inputs? So can I open these 2 inputs? No. Now the 2 inputs not used are connected to ground. Can I connect these to ground? Means connecting the ground means these are given to 0, 0. If I given to 0, 0, can I it will it work like a NOT gate? Then what happens? Tell me here. A into 0 whole bar. So that means what will get now 0 bar, which will get this as 1. It does not work like a NOT gate na inverter. So that's why this is also not correct. The 2 inputs which are not used connected to VCC. Connected to VCC means what? Given to logic 1 na? 1 1 if I given. Tell me what happens now. This is A into 1 whole bar, which is nothing but what now here? A bar. So ये आएगा कि नहीं बोलो? Option C चलेगा. Then next, The output for the logic circuit shown in the figure is, the output for the logic circuit shown in the figure is, now you see here, here we have, this is a plus a bar. For this whole bar, a plus a bar is 1, one whole bar which is a 0, and because here we have bubble is there, that will be a 1. Next here this is a into b bar, and here this is what we can tell me now, here this is ab bar whole bar, and this is what you tell me now, here ab bar, bar will get cancelled. Now here this is 1 into what you tell me now, here ab bar. So tell me now output what I will get here, that is ab bar plus what you tell me now, here ab bar, both are ab bar only. So which will be given as ab bar, one ab bar will give, remove now, done. Next, the circuit shown in the figure is equivalent to, now here we have a, how many levels are there, 2 levels are there, and see the logic now, here in the level 1 what we have, it is an OR gate. Level 2 what gate, sorry, level 1 what we have, NOR gates. So we have this as a NOR gate. Level 2 we have a NOR gate. So this is the 2 level NOR logic. As we know here, that is 2 level OR and logic. 2 level OR and logic, which is equal to what I can say, which is identically equal to 2 level NOR logic. Is identically equal to 2 level NOR logic. So tell me the कौन सा option here. So level 1 में, so here OR gate, level 2 में AND gate होना पड़ेगा. Same input. सुनो option A. So option A में चलेगा, बोलिए. All of you. Yes, the logic gates also we have completed, 50 we have completed, right? If you don't remember, then you just imagine you have taken as some inputs you take here. This is A, B, let us say C, D, and you take the some inputs. Now simplify it. Now find out this output here and verify, so normal method. So this logic try to remember. If not, so then take the some inputs and find the output, and you need to verify from the all the options we have to verify in that cases. Done. Yes, completed all of you this thing. Next one. Now tell me the next one. The logic circuit in the figure can be minimized to what? Yeah, here we'll get this as a x bar. Here what I am getting now here, this is x plus y bar. So means what we can say, this is x bar into y bar. If I say this is my output f, tell me the f here, which is given as x bar plus x bar into y bar whole bar. So this means what I can say, this is x bar whole bar into this is x bar into y bar whole bar. So that means which is equal to x into, tell me now here, x plus y, which is given as x plus xy, which is equal to what I'll get, x only. So I can say option D na. So this is the buffer. What is this is a? This is what na, buffer na. No need of any gate now. If I given this is x, here we'll get this as x only will come as output. Next, yeah, see this thing here in the figure shown. So x2, x1 will be the ones complement of a. So they are saying this as what you tell me now. These are the ones complement of a. Now you tell me that means here this is, we have this is my a naught. Now what they are saying, this as x naught is given as a naught bar. This they calling it as a1 bar. And this they are calling it as what you tell me now here, a2 bar. Now these are complements, means what should be the y value I need to give. For that y I need to give this as 1 na. If I given 1, then only this is 1 XOR with a naught. I will get this as complement na. 1 XOR with a1. I'll get a1 bar. 1 XOR with a2. I'll get this a2 bar. Isn't it? So what the condition, tell me now, y must be is 1. Next, the minimized logic circuit. If I call this is my f. Yeah, tell me now f, what I'll get here. This is my x bar and this is my z bar. So tell me now what I am getting the f here. That is x bar plus what? X into y bar z whole bar plus what now here, z bar. Simplify here, what I'll get now here, x bar plus, now I will get this thing as x bar plus y plus z bar plus z bar. Then all of you, now let's simplify it now. X bar plus y plus z bar. This which we can write in terms of NAND gates, this is x, y bar, z whole bar we can say na. So kaun sa option, tell me here? Why D, check it. D na. Right. Next. Now tell me the minimized expression here, simplified form. Here we'll get this as AB bar. Here I will get this as, tell me now here, AB bar into C whole bar. Yeah, what here? This is by using NAND gate here. X we have here. See this thing. NAND gate inputs are what you tell me? X, Y bar, Z. So this is X, Y bar, Z na. Yes. So how the D now here? If you have what I will get the D? You tell me here. This is X bar, Y Z. So but here it is what now, x bar plus y plus z na. This is the addition we have, not the multiplication. Now tell me, this is the summation, sum. Here we have multiplication will come na. So this is option. Yeah, tell me now here what I'll get now here. This is my DE bar. So if I call this output is F. Yeah, tell me now F is given as what I'll get. So this is my AB bar into C whole bar into DE bar whole bar. So then F is given as what I'll get now here, AB bar into C plus what you tell me now, DE. Check it all of you. So what I'll get now here. So this F A, I can write this thing as A bar plus B bar into C plus what, DE. Yeah, tell me the option here. Next, see the next problem. Now here what I am getting now here, A plus B bar. Here B plus C, isn't it? Here this is B, isn't it? And here I am getting the A plus B bar into B plus C. So finally output Y, what I'll get, you tell me? A plus B bar into B plus C into B. Yes or no? Into B. Now first if we multiply this with this, we will get this as AB plus what now? 0. B into B bar 0. Next B plus C. So what I'll get now here, which is equal to AB plus what you tell me now here, ABC. So I can take AB common here, then it is 1 plus C. So finally Y is equal to, tell me now what I will get, AB. Next, here also this is the open collector output. So you treat this connection as what you tell me here, treat this as a AND gate. Treat this as a AND gate. Now tell me the Y value here. This is A plus B bar, yes, into, tell me now here, C plus D whole bar. So what I will get, you tell me now, I can say this is A bar into B bar tell me now what I will get now here, into C bar into D bar. And so this is also, we can write it as, this is A plus B plus C plus D whole bar also I can write now. So you can see B and D both are correct, check it. B and D both are correct. All of you tell me. Next, and you can see now this is you can see now this is directly हमारा बर्फी है ना, बोलिए. This is हमारा बर्फी. बर्फी here, tell me the NAND बर्फी ना here. So NAND बर्फी बोले तो directly we can say this as XOR gate ना. which is a XOR gate. Directly we can write. Next. Now here you see this thing here. Now what we can do here? This is a NOR gate. Look at now here. Here this bubble is there. Now this bubble I'm shifting to here. Then I remove this bubble here. I can shifting to here. Bubble means not gate now. This bubble remove here and shift to here. This bubble remove here, shift to here. Can I do like this? The bubble means not a gate. So you see this is exactly option D. That is exactly option D. So the NOR gate का bubble sign of those are shifted to the आगे, थोड़ा आगे शिफ्ट किया उन्होंने. सो यहाँ से लेके इधर शिफ्ट किया. बबल मीन्स व्हाट? नॉट a gate. Done. Next. Yeah, tell me here. Here we'll get this as A plus B. Next here, this is what you tell me. A plus B into the whole bar. Now this is like a NAND gate. So we can say DE whole bar. So finally output क्या मिलेगा बोलो? This is A plus B into C bar into DE bar for the whole bar. Now you tell me now why, what I'll get here. A plus B into C plus what you tell me now here, DE. बोलिए कौन सा ऑप्शन here? A. Done. Next. The output of the given circuit is. Now tell me now here, this is now here X XOR X is equal to, tell me now, 0. Same inputs, output is 0 now, tell me. Now this is 0 and this is X. Now tell me now here 0 XOR with X. So agar input is 0 hai to it is like a buffer. Now tell me X only will come. That means this is X and A भी X है ना. अभी बोलो this is X XOR with X. Same input case, output is 0 now, tell me. So that's why what I can write now here, output which is equal to what you tell me, 0. आना बोलिए. Yeah, like this we have solved the problems we have done. Yes, finally we have completed हमारा target में हमने finish किया 2 घंटे में. So 60 problems day. And the same manner will meet tomorrow. Tomorrow also same timing 10 o'clock and tomorrow also 10 to 12, and we'll try to finish the another 60 problems. Yes, and regarding this PDF and all, what we can do here, you can join the Telegram group, that is BV Reddy Gate. You can join me in the Telegram channel. There you can get BV Reddy Gate. You can search in the Telegram channel this name. You can join in this thing here. There you can get the this complete PDF आपको मिलेगा. There you will get the complete this PDF मिलेगा. So what are the problems we have finished? That PDF here it is available. Okay, fine. Yeah, that's for the today's class. We'll meet tomorrow. Hope you enjoyed the class today. We'll meet in the tomorrow class. See you. Bye bye. Take care. And once again, happy Mahasivaratri to all of you.